Hi, this is Antosh Dade. In this video, we will discuss namespace in DNS. In computing, a namespace is a set of symbols that are used to organize objects of various kinds so that these objects may be referred to by name. A namespace ensures that all the identifiers within it have a unique names so that they can be easily identified. In DNS, a namespace that maps each addresses to a unique name, and it is organized in two ways: flat namespace and hierarchical namespace. Before the domain name structure was developed, computer names and IP addresses were mapped using a flat list and stored in a simple text file called hosts file. In flat namespace, a name consists of sequence of characters without structure. The flat namespace cannot be used in a large system such as Internet, as it must be centrally controlled to avoid ambiguity and duplication. As we understood from the previous video on need for DNS, the centralized access may create huge amount of traffic on the Internet, which may delay the response from the server. Hierarchical namespace is made up of several parts. The first part defines the nature of the organization. The second part defines the name of the organization. The third part defines the department in the organization, and so on. The hierarchical namespace is a decentralized naming system where the central authority can assign the part of the name that defines nature of the organization and the name of the organization. The rest of the namespace can be given by the organization itself. The organization can define its host name without worry of duplication over the internet. For example, docs.google.com. Here, .com is a commercial organization and Google is the name of the organization. These two names are given by the central authority. However, docs namespace is created by Google without worrying of duplication of the namespace over the internet. Domain namespace has designed to arrange in hierarchical namespace. Here, names are defined in an inverted tree structure with the root at the top. The tree can have only 128 levels starting from level 0 to level 127. Each node in the tree has a label of maximum 63 characters. The root label is null string, that is empty string. Each node in the tree has a domain name. A full domain name is a sequence of labels separated by dots and always read from the node up to the root and ends with a dot. For example, cn.antosh.in, docs.google.com, forms.google.com, etc. If a label terminating by null string is called a fully qualified domain name, FQDN, it contains all labels from host to root. For example, cn.antosh.in. In partially qualified domain name, PQDN starts from a node but does not reach the root. PQDN used to resolve the client in the same site. For example, user from cn.antosh.in wants to get the IP address of CN and he defines CN as a PQDN. A domain is a subtree of the domain namespace, and domain name is the name of the top node of the subtree. The domain may itself divide into domains known as subdomains. The information contained in the domain namespace must be sorted and stored on different servers called zones. It is not reliable to have one system to store the huge amount of information, which may create heavy load on the system and may be chances of failure. The zone is a contiguous part of the entire tree. The server creates zone file and keep all the information of every node under that domain. The whole space is divided into many domains. The root is the first level domain. It is further divided into smaller domains called as subdomains. The root server zone consists of whole tree. However, it does not store any information about domains, but delegates its authority to the other server, keeping reference to those servers. There are several root servers distributed all around the world. Here you can see root is having top level domain as .com, .org, .edu, .net. Second level domains as .mci, .att, .berkeley. Berkeley.edu has a CS as subdomain and EOS as host system. DNS defines two types of servers, primary and secondary. A primary server stores zone file and has an authority for creating, maintaining and updating zone file stored in the local disk. However, secondary server neither create nor update the zone file. Instead, it transfers the complete zone file from primary server. The secondary server acts as a redundancy for the data so that if one server fails, the other can continue serving. In the next video, we will discuss the topic on DNS in the internet. Thank you for watching this video. Have a good day.